for a given sequence, and they can get pretty complex. I'm just going to do some of the basic things you can do or that might come up. Here's a very basic one, 2, 4, 6, 8. We want to write an equation so that they could say, what's the 200th term in this sequence? And we could easily just throw it into that equation and find it rather than having to sit down and write out 2, 4, 6, 8, 10, 12 until we get to the 200th term. Okay, so that's why they like to have a formula. A lot of times the way we would write those is, for example, A sub n. Okay, so this means this is the amount for the nth term. And then we would want to find some way, so what are we doing each time? That's kind of the basic question you would ask as you try to set this up. Well, we have all even numbers here, right? So this is 2, and then if we go times 2, well, actually if we add 2, okay, but notice those are all even terms, so as we add 2, we end up on another even number. We can't just put n plus 2. If we wanted to write it that way, we'd have to put this is our first term, and the next term you add 1, and that's really not quite as helpful. But we could say, if you just take n and multiply it by 2, starting at n being 1 and going up from there, notice that would do it for us. Because when n is 1, 2 times 1 would give us 2. When n is 2, our next term, 2 times 2 gives us 4. What this does is just gives us even numbers, because we know that any number that can be divided by 2 is even, which means if we multiply by anything by 2, it will make it an even number. Okay, if we did the third term, we'd get 2 times 3 is 6, and the fourth term, 2 times 4 is 8. So if we wanted to know the 200th term, it would be 2 times 200, or 400. So the answer to this question, find a formula for the nth term of the sequence given by 2, 4, 6, 8. Our answer would be a sub n equals 2 times n for n being greater than or equal to 1. Okay, so again, this just means the amount for the nth term, so the first, second, third, fourth, whichever term you're on, is equal to 2 times that term. And we are starting at 1 and going up from there. Okay, we're going to put a twist on that one. So this time we have a formula, and this is just something basic that happens quite a bit. So I'm going to show you how to get when you end up with a sequence that has alternating positive and negative. Okay, so you see this is exactly the same as our previous problem, except for every other number is negative. So we can take care of the 2, 4, 6, 8 by, say, if we just said, like we did last time, a sub n is 2 times our term starting at 1. Problem is we want every other term to be negative. So notice if we multiply by negative 1, that would not change our numbers, but would make it, except for making it negative. Problem is we only want it to be every other term. So what you do when that happens is you take negative 1 and multiply it, but we only want it to happen every other time. So we're going to say raise that to the n plus 1 power, because every time this is an even power, that will be positive 1. Anytime it's an odd power, it will end up being negative 1 and will make the number negative. Let's try out this sequence. Always try it out to see if it works. So if we did this starting at 1, okay, if our n is 1, so we put 1 in both places, we'd have 1 plus 1 is 2. Okay, try this out. So we have negative 1 squared times 2 times 1. Well, negative 1 squared is positive 1 times 2 times 1 is positive 2. But when we get to the second term, notice a sub 2, we'd have negative 1 to the 2 plus 1 power, or third, 2 times 2. Negative 1 to the third power, anytime we have an odd power, it's going to make it negative. Okay, so we'd have negative 1 times 4, or negative 4. Okay, and that's going to give us our alternating negative sign. So if you have alternating positive negatives, that's what you want to do. You want to put a negative 1 raised to a power. So our answer would be a sub n, or the nth term, would be negative 1 to the n plus 1 power times 2n, starting at n equals 1 and going greater than that. I know these are a little tricky, but that's one trick that might come up from time to time. That's how you get alternating positive and negative. Okay, here is our final example. 1/3, 1/5, 1/7, 1/9. Okay, so the first thing you may notice is that these are all fractions. So probably our equation is going to have a fraction with 1 on the top. Notice they all have a 1 on the top. On the bottom, we're getting odd numbers instead of even numbers. Okay, so we can't multiply by something and always make it an odd number like we could with the 2 to make it even. But notice that if you take an even number and add 1 to it, that will put you on an odd number. Okay, because an odd number always comes after an even. To create our even numbers, we took 2 times n. So if we just take 2 times n and add 1 more, that will give us odd numbers instead of even. And all throughout mathematics, when someone's trying to create odd numbers, this is what they use, the 2 times n plus 1, because that always gives us odd numbers. Okay, let's try that out. Is this going to work? And what do we want to start on? We want to start with a 3 in the denominator. So 2 plus 1 would be 3. Let's start at n being 1 and go up from there. So let's try it out just to make sure we did it right. So our first term would be 1 over 2 times 1 plus 1, which would be 1 over 3. So our first term worked. Let's keep going and check this out. Our second term would be when n is 2, so we'd have 1 over 2 times 2 plus 1, or 1 over 4 plus 1 is 5. 1/5. Look at that. It seems to be working. Let's try one more just to make sure. We have 1 over 2 times 3 plus 1 gives us 1 over 6 plus 1 is 7. So that is working. So our answer is that a sub n, or the nth term, is equal to 1 over 2n plus 1, where n is greater than or equal to 1.